Imagine you're lost in a dense forest, your phone's battery is dying, and the sun is starting to set. Just as panic sets in, you pull out a small device, press a button, and, like magic, it tells you exactly where you are and how to get home. That's the power of GPS, a technology so woven into our lives that most of us never stop to wonder, how does it actually work? Today, let's unravel the secrets behind GPS, peeking into the world of satellites, Einstein's relativity, and the clever math of triangulation. High above us, orbiting the Earth, is a constellation of at least 24 satellites, each equipped with ultra-precise atomic clocks. These satellites are constantly broadcasting two things: their exact position in space and the precise time their signal is sent. Your phone or car's GPS receiver listens for these signals, but here's the twist. It needs signals from at least 4 satellites to pinpoint your location. So how does your device turn these signals into an exact spot on the map? The answer lies in a process called trilateration. When your receiver picks up a signal from a satellite, it calculates how long the signal took to arrive. Since radio waves travel at the speed of light, even a tiny error in timing can throw off your location by kilometers. That's why those atomic clocks are so important. They keep time to within a few nanoseconds. But there's another mind-bending layer: relativity. According to Einstein, time ticks differently for satellites in orbit than it does for us on the ground. Special relativity says that moving clocks run slow, while general relativity says clocks higher up in Earth's weaker gravity actually run faster. These effects don't cancel each other out. So without correcting for relativity, GPS would be off by miles within a single day. Early GPS engineers learned this the hard way and now rely on Einstein's equations to keep everything synchronized. Once your receiver gets the timing and position data from at least 4 satellites, it solves a set of equations to figure out exactly where you are: latitude, longitude, and even altitude. This is what allows you to track a pizza delivery, navigate a road trip, or find your way out of that forest with astonishing accuracy. So the next time you tap your phone for directions, remember, you're harnessing a global network of satellites, atomic clocks, and the mind-bending effects of relativity, all working together to answer one simple question: where am I? That's the magic and the science behind GPS. Liked what you saw? Then hit that like button, share your ideas and thoughts in the comments, and subscribe so you never miss a moment